Okay, welcome back, everybody. We are still in Chapter 5, Section 3, and we are still solving trig equations. You're still going to want your unit circles, so if you have that, maybe pause the video and go get that if you don't have it handy. Up until this point, we've just been solving equations that are sine of x equals something or cosine of x equals something. In this lesson, we're going to solve for multiple angles or half angles. So that means things like sine of 2x or cosine of 1/2 x. So what we're going to do is we're going to solve like we did before for this product, for that KU thing. And we'll use our unit circles to help us. And then we'll continue solving to find just the value of x. So let's jump right in with this first example. We're going to solve 2 cosine 3t minus 1 equals 0, and we want to find the general solution. Remember that these functions, cosine and sine, secant and cosecant, all have infinite domains. So that means when I'm finding the general function, I'm going to have to add that little thing at the end, the 2 pi n, because it just repeats over and over and over again. And I'm not given a specific domain to limit all of my answers. So that's what the general solution means. Okay, so I'm going to dive right in. I'm going to start by adding 1 to both sides and then dividing by 2 so that I get cosine 3t equals 1 divided by 2. Now I'm going to think to myself, if I use inverse functions, I want to know what angle, when I take the cosine of it, equals positive 1/2. So if I go to my unit circle, the cosine is the x values. So positive 1/2 is here, and then positive 1/2 is also here. Those correspond with pi over 3 angle and 5 pi over 3 angle. So we know that if we did the inverse functions, we would have 3t is equal to pi over 3, and 3t is equal to 5 pi over 3. All right, at this point, we're going to add the 2 pi n to each of those. And then we're going to solve just for t, or just for the variable. So on the left-hand side, I'm going to multiply by 1/3, which is the same as dividing by 3. And on the right-hand side, I'm going to multiply by 1/3, which is the same as dividing by 3. I'm going to distribute that to both sides, so I just get t equals pi plus, oh, sorry, no I don't, equals pi over 9 plus 2 pi n over 3. So that's one of the answers. The second one, I'm going to do the same thing. Divide by 3 on the left, which is the same as multiplying by 1/3. So I get t equals 5 pi over 9 plus 2 pi n divided by 3. Recall that when you have this multiple inside the function, that it changes the period. So this is that 3 value that we had to divide everything by, that's changing the period. And that's why we're able to find these values. So this, both of these are the general solution. If you think about it graphically, this is the graph, cosine 3x and 1/2. So the red line is the 1/2, and the cosine 3x is the blue curve. This is from 0 to 2 pi. So you can see, here's our first answer. Here's our second answer. And then because it's cyclical, the first answer repeats here, and the first answer repeats here again. the second answer repeats here and here. So you can see how the curve of the cosine gets intersected by that red line in multiple locations, as if you were going around the unit circle over and over and over again. Okay, why don't you pause the video here and try this one? Okay, in this example, sine 2x is already isolated, so we're going to use our inverse trig and our unit circle to figure out that the sine of x equals negative root 3 over 2 when we have 5 pi over 3 or an angle of 4 pi over 3. So we set each of those equal to 2x, so 2x equals 5 pi over 3 plus the domain. Or 2x equals 4 pi over 3 plus the domain. We divide by 2 on both sides, and we end up getting these two final parts as our solution. Cool. All right, let's do another example together. So using the tangent, we have 3 tangent x over 2 plus 3 equals 0. So I'm going to start by subtracting 3 and then dividing by 3. So I have tangent x over 2 equals negative 1, because I would subtract 3 to get negative 3, divide the whole thing by 3. Okay, so I'm going to go to my unit circle, and on my unit circle, I know that tangents are sines over cosines, and the only place where sine over cosine would be equal to negative 1 would be where those values are opposites of each other. So we're looking at here or here. The thing is, we're using our unit circle, and we know that we're basically in those locations. The thing is, we're talking about the domain of the tangent, and the domain of the tangent is from 0 to pi. So since we're moving in a negative direction, we're talking about this angle here, which is 3 pi over 4. Oops, sorry. Circled the wrong one. This one, which is 3 pi over 4. Okay, so we use our inverse operations. We have x over 2 equals 3 pi over 4. In this case, our domain is pi, so we're just going to do the plus pi n. In order to solve, we need to multiply by 2 on both sides. So we get x on the left, and this 2 gets distributed to each part. So we've got 6 pi over 4 plus 2 pi n. So I'm going to go ahead and simplify that into 3 pi over 2 plus 2 pi n. So that's the general form for the solution for this equation. All right, here's another one for you to try on your own. Okay, here's the solution. This was convenient because we had already found the angles here. We knew that negative root 3 over 2, the sine of 4 pi over 3 equals negative root 3 over 2, and the sine of 5 pi over 3 equals negative root 3 over 2. So here, now that it's equal to x over 2, we just have to multiply by 2 on both sides. We have to distribute the 2 everywhere, and these should be your solutions. Okay, awesome. Now, what happens if you are actually given an interval on which you have to find all the answers? So here, instead of just writing a general formula, we're actually going to have to find all of the answers to the solution. So we're going to use the exact same steps that we've been doing, but once we get our general formula, we're then going to start inputting values of n. So n equals 0, because that would be 0 times around the unit circle. N equals 1, that's 1 time around the unit circle. N equals 2, etc. to find all the values that fit into this particular interval, which is just one domain from 0 to 2 pi. Okay, so let's start here. We have cosecant 2x equals -1. We don't need to isolate anything because the trig value is already isolated. So we do need to figure out where does the cosecant equal -1. And remember that the cosecant is the same as 1 over the sine. So in order to have -1 over 1, that would be the same as +1 over -1. That's only going to happen at 3 pi over 2. So we go and write down 2x equals 3 pi over 2. Now our interval is going to be, or our domain is plus 2 pi n. So we know that we are repeating our cycles over and over again. So now we're going to solve for x. So divide by 2 on both sides, or multiply by 1/2. And we get x equals 3 pi over 4 plus pi n. So this is our general formula, but we want to find the actual values on the interval from 0 to 2 pi. So we're going to take values of n and just plug them in, and we'll keep doing that until we find ourselves outside the limits of 2 pi. So for n equals 0, we would just get 3 pi over 4. Because if you plug in 0 for n here, that would be eliminated, so you just get 3 pi over 4. Okay, then let's do n equals 1. We would have 3 pi over 4 plus pi times 1, which is just pi. So when we add those together, pi is 4 pi over 4. So this gives us 7 pi over 4. All right, we'll keep going because we're still within that interval. So let's say n equals 2. If we plug in n equals 2, well, now we have 3 pi over 4 plus 2 pi. Well, that ends up being 3 pi over 4 plus 8 pi over 4, which is 11 pi over 4. And that's too big. That's outside of our domain. So we actually don't need this solution. So our two solutions, are 3 pi over 4 and 7 pi over 4. All right, why don't you use that knowledge and try this next example? Okay, after you've tried it yourself, you divided by 2 on both sides, and you got cosine 4x equals -1/2. The cosine of x equals -1/2 at 2 pi over 3 and 4 pi over 3. So we now can write 4x equals 2 pi over 3 plus our domain 2 pi n, or 4x equals 4 pi over 3 plus our domain 2 pi n. On both of these, we're now going to solve by dividing by 4 on both sides. So we end up with these two general solutions: pi over 6 plus pi n over 2, and pi over 3 plus pi n over 2. Now we'll take values of n and substitute them in until we exceed our domain, because we want all of the answers on the interval from 0 to 2 pi. So you can see here I started with n equals 1, and I plugged it into my general formula to get 2 pi over 3. I'm sorry, I started with n equals 0. So we just get pi over 6 and pi over 3. Then I moved on to n equals 1, plug that in to solve. So I've got these solutions. Then I went to n equals 2, plugged that in to solve. Then I went to n equals 3, plugged that in to solve. And when I went to n equals 4, I got to this point where that add-on was 2 pi. So that means anything I add to that is going to be greater than 2 pi, therefore it's not part of our solution. So our answer actually has 6 different parts, and they're all listed here. Okay, there are 8 practice problems for you to work on. Thank you.